Hi, this is Video Explainer 1, and I'm going to be solving this Mastering Physics problem. Block 1 of mass M1 is 3.9 kilograms, moves along a frictionless air track with a speed of velocity of 23 meters per second. It collides with block 2 of mass M sub 2, which is 53 kilograms, which was initially at rest. The blocks stick together after the collision. So this problem is going to deal with inelastic collisions that occur in this system. So the system pertaining in this problem is two blocks, and they're interacting with each other due to the momentum of block 1. So to set up this problem, I drew out this visual diagram to represent what's going on in this problem. So the system before the collision, you can see block 1 and block 2 are apart. Block 1 is traveling at an initial speed of v sub 1, which is 23 meters per second. And as the problem said, block 2 is at rest, so its initial velocity is 0. And then the system after the collision, you can see the two blocks are stuck together due to the force of the collision. The total mass of the system now is mass 1 plus mass 2. And the final velocity is the combined velocity of the entire system. And so part A is asking, find the magnitude of the initial momentum of the total initial momentum of the two block system. So what I did to solve this problem was I set up a system that represents the two blocks that are within it. So for both blocks, I wrote out the mass and the initial velocities. And so one of the primary equations we're going to be using for this problem is the momentum equation, which momentum equals mass times velocity. And so to find the initial momentum, we're going to be using the initial values that we were given, as well as the values for the mass. So I found the momentum of block 1, which is 89.7 kilograms times meters per second. And then for block 2, since the initial velocity is at rest, the velocity is going to be 0, and that actually creates a 0 initial momentum for block 2, which makes sense because it's not moving. And so the initial magnitude for the initial momentum is going to be equal to the momentum of block 1. So the initial momentum is 89.7 kilograms times meters per second. So part B is asking to find the final velocity, the magnitude of the final velocity of the two block system. So I know that to find the velocity, we can also use the equation for momentum. In this case, we can assume that the velocity is going to be representing the final velocity. So we can rearrange this equation, and we also have to remember that since the final velocity involves the masses of both blocks, since it's considered one system, so it's going to be divided by mass 1 plus mass 2. So the final velocity is going to be the initial momentum of the system, which is calculated above, as well as the sum of the two masses. So we get final velocity is equal to 89.7 kilograms meters per second divided by 56.9 kilograms. And we get a magnitude final velocity is 1.58 meters per second. So the last part of this problem is asking, what is the change in the kinetic energy in the two block systems kinetic energy due to the collision? So it's also giving us this equation, the change in kinetic energy is equal to the final minus initial energies. And so I know that in order to represent the kinetic energy of a system, we have to use this equation, which allows us to incorporate all of the values for the masses and the initial velocities for the two blocks. And so to find the initial kinetic energy, I used this equation, and I used the initial velocities for both blocks. So in this case, The initial velocity for block 1 is 23 meters per second, and again, the initial velocity for block 2 is 0 meters per second since it's at rest. And so I get that the initial kinetic energy is 1,030 joules. And so I did the same thing for in order to find the final velocity, except this time we're going to be using the same velocity for both portions of the equation for block 1 and block 2, since the final kinetic energy is pertaining to the two-block system, and the two-block system has one final velocity, which is calculated to be 1.58 meters per second. So again, I plugged in those values, and I got a final kinetic energy of 71.0216 joules. And so finally, we can use this equation where the change in kinetic energy is equal to the final kinetic or final minus initial. So I did that calculation and I got a change in kinetic energy to be negative 958.98 joules. So something that I think is tricky about this problem personally is just remembering when to use which variable, particularly in this section, just remembering to make sure to add the two masses together to get the mass of the entire system versus calculating the mass or calculating the final velocity for only one of the blocks. It's important to remember to use both masses so we can do the correct calculation. And also, I think another tricky part is like determining which equation to use to calculate the final and the initial. I think it can be a bit easy to mix it up and just use one set of variables instead of using both sets of mass 1, velocity 1, mass 2, velocity 2, and then figuring out to change the velocity in the final kinetic energy calculation to what we calculated to be the final velocity. Thank you.